Tronox is the world's leading vertically integrated manufacturer of titanium dioxide pigment. But what does that mean? It means that we can streamline our operations, save money, and in many cases, meet our own production needs because we control our own supply chain. We mine mineral sands in Australia and South Africa to produce feedstock materials that are used to make TiO₂ pigment, high-purity titanium chemicals, and ultra-fine TiO₂ used in certain specialty applications. We also benefit from the production of valuable high-grade zircon, pig iron, and activated carbon. 90% of our Thai feedstock products end up as pigment, and our mining operations supply 85% of the feedstock needed to make our world-class TiO₂ products. Said another way, turning black powder to white pigment is the magic of Tronox. Let's break it down a bit more. Tronox operates multiple mines that employ diverse mining techniques. Dry mining, conducted at our mining operations in South Africa and Australia, uses earth-moving equipment to excavate and transport the sands for processing. Monitor or wet mining entails blasting the face of a mine with a water jet, allowing the sand and heavy minerals to be carried away for separation. Tronox uses wet mining in South Africa. In dredge mining, a huge wheel cuts through the bottom of a mining pod and digs up sands and heavy minerals, then pumps it into a floating concentrator or separator. By selecting these mining techniques, and beginning with the end in mind, we minimize our impact on the land, ensure swift rehabilitation and restoration, and leave the native flora and fauna in a better condition than we found it. Once the ore is mined, it is processed into heavy mineral concentrate, which then goes to our mineral separation plants, or MSPs, where we use various separation techniques, gravity, magnetic, and electrostatic, to divide the rutile, leucoxene, and ilmenite. The ilmenite is further refined for use in TiO₂ pigment manufacturing to remove iron and other non-titanium material. This is done by smelting ilmenite in an electric arc furnace to make titanium slag, or by reducing ilmenite in a rotary kiln to make synthetic rutile. Once separated or upgraded, we transport our titanium-rich ore to our pigment plants to go through the chloride or sulfate process. In the chloride process, titanium-rich ore is fed into a chlorinator together with coke and chlorine to produce titanium tetrachloride and other metallic chlorides. Next, the produced titanium tetrachloride is condensed, then purified, to produce pure TiCl4, which is then oxidized at high temperatures to create raw titanium dioxide pigments. The final stage includes the treatment and milling process, resulting with different grades of finished products. In the sulfate process, we treat ilmenite with sulfuric acid, and the resulting titanyl sulfate solution is then hydrolyzed to produce pure TiO₂ slurry, which is then used to make TiO₂ pigment or ultrafine TiO₂. For TiO₂ pigment, the TiO₂ slurry is calcinated at high temperatures, treated and milled to provide various grades of finished products. For ultrafine TiO₂, the TiO₂ slurry receives a specific treatment and then is dried or calcined before packaging as a sol or powder. We also use the sulfate process to produce crystal-active TiO₂, which has a wide range of physical properties. We package and ship those products to customers all over the world for use in a wide variety of applications and products. Look around you. Where can you spot the TiO₂? The paint on your walls, the screen on your device, the filters in your air conditioner, the coatings on your furniture, and many more everyday products all contain this critical material. TiO₂, in its ultrafine form, is a key element for the reduction of noxious emissions in transportation and power generation. Zircon is in ceramic tiles, tableware, and sanitary ware. Our pig iron can be found in castings for automotive, engineering, and oil and gas components. Activated carbon is used in the purification of food and beverages, as well as water treatment and soil rehabilitation. And the R&D teams at our research centers continue to innovate to develop additional uses to meet customers' needs. Tyona TiO₂ offers exceptional whiteness, brightness, and opacity. Compared to alternative white pigments, it can cover, mask, or protect materials more effectively and efficiently. Simply put, there is no substitute for TiO₂, because no other material is as opaque or bright.